Hello, Mr. Hat. This is problem number 5 of the 2008 FRQ. So it reads, the derivative of a function f is given by f prime of x is equal to x. This is so boring, Mr. Hat. You know, I'll be right back. Just give me a sec. Here we are. Well, that problem looks so boring I couldn't even bear looking at it. So I decided to take a few liberties and, change a few of the words around and hopefully make it a little more interesting for both you and I, because I know that you're probably sitting here watching 10 different of these videos and being bored out of your mind. So, without any hesitation or pauses, let us begin. Mr. Happ has a ridiculous tendency to pull his muscles, especially his groin. However, due to Mr. Happ's most strange physiology, he doesn't notice it at first. The derivative of a function f, which describes the level of pain he experiences, is given by f prime of x is equal to x minus 3 times e to the x for x is greater than 0, and f of 1 is equal to 7. Part A. The function f has a critical point at x is equal to 3. At this point, is Mr. Happ relatively okay, relatively dying of pain, or neither of those? Essentially, the original question was, does f have a relative minimum, relative maximum, or neither? Justify your answer. So all we need to do here is really take values about x is equal to 3 and plug them into f prime of x to see whether the values yielded are negative or positive. So if you take x is equal to 1, which is less than 3 obviously, we'll get f prime of x is equal to 1 minus 3 times e to the first power, which is equal to minus 2e. If we take x is equal to 4, which is greater than 3, we will get the value of f prime of x is equal to 4 minus 3 times e to the fourth power, which is equal to e to the fourth. Now, because f prime of x changes from negative to positive at x is equal to 3, Mr. Happ is relatively okay, hence there exists a relative minimum at x is equal to 3. Parte B. On what intervals, if any, is Mr. Happ's pain level both decreasing and the rate of which his pain decreases? Or, in more simple terms, on what intervals, if any, is the graph of f both decreasing and concave up? Explain your reasoning. Essentially, for this one, all we want is the interval in which f prime of x is less than 0 and f double prime of x is greater than 0. We already know that f prime of x is less than 0 for the interval 0 is less than x is less than 3. For f double prime of x, we will first need to find f double prime of x. If we take the derivative of x minus 3 times e to the x power through whatever method you want, either through distributing the expression first or taking the derivative as a whole and using product rule, you will get the f double prime of x is equal to x minus 2 times e to the x power. We can immediately see from this that f double prime of x is greater than 0 whenever x is greater than 2. Therefore, Mr. Happ's pain level is decreasing, and the rate at which his pain decreases is decreasing between 2 and 3. That sentence did not make any sense, I'm sorry. Part C. Jonathan also pulled his groin once. True story. I will demonstrate momentarily. And has unfortunately the same strange physiology Mr. Happ possesses. Find the value of the pain he experiences at f of 3. Alright, so in this case we'll just do f of 3 is equal to the initial condition, which is f of 1, plus the integral from 1 to 3 of f prime of x dx. Since f of 1 is equal to 7 as given in the original problem, we have 7 plus the integral from 1 to 3 of x minus 3 times e to the x dx, which I forgot to write, and we'll do so right now. Oop. Careless me. Don't do that on the AP exam, otherwise you'll get screwed over. Alright, so let's isolate the integral, and then we're going to integrate it by parts. We'll have our u be x minus 3 because the derivative of u is going to be 1 in that case, while dv is equal to e to the x, which integral of that is equal to e to the x. Now if we integrate by parts, we get e to the x times x minus 3, which is basically just u times v, minus the integral from 1 to 3 of du times v. This yields us the initial part, which is e to the x times x minus 3, is going to be equivalent to 2e. The integral is going to be equivalent to the expression of e to the third minus e. Now, if you finish integration by parts, we get our final answer of 3e minus e cubed, which is still only our integral, so we have to plug that back into our original equation, which was f of 1 plus the integral, in order to get our final answer, which is 7 plus 3e minus e cubed. Now, surprisingly enough, this turns out to become minus 4.93, which means that at this point, Jonathan is feeling pretty spiffy, even though he just pulled his groin. Yeah. There aren't really too many common errors one could make in Part A unless you truly do not know the fundamental concepts behind the problem. The one probably most common error one would find is that you simply cannot use only this table as justification for as to why there's a relative minimum at x is equal to 3. So this is a no. You cannot only use that table. You have to have some other justification, whether it be in a sentence or something else. As with Part A, there aren't too many common errors one could make while doing this. If you did not get the problem, it would be more likely that one did not understand the fundamental concepts behind Part B rather than actually making a common or silly error. The two errors I can really see to be the most common are either forgetting the fact that we already know that f prime of x is less than 0 between 0 is less than x is less than 3 from Part A, or taking the double derivative needlessly complicated by firstly distributing out x minus 3 times e to the x power before differentiating the expression rather than simply differentiating as is. Part C has the greatest capacity for error because it is the most complicated part out of the three parts. Firstly, one could forget that f of 1 was given in the initial premises of the problem, and if one does not incorporate that into their expression, their answer will be off. Secondly is a failure to identify the integral as by parts or as an integration by parts problem. There's also the matter of sometimes switching the u's and v's around, which can lead to a needlessly complicated, disgusting-looking expression which cannot be simplified. Another problem or error could be simply forgetting that u times v is a separate, distinct entity from the integral of du times v. Finally, there's the matter of after you find your integral, you have to plug it back into the expression, which is something I forgot to do a billion times in the previous tests. So you have to, after you find the integral, you plug it back into the original expression to get your final answer. That's all. Thanks for watching, I guess, and Mr. Happ, thanks for covering me yesterday at prom. I appreciate it.